Today's lecture is about gravitational force. What's gravitational force? It is a force that attracts two masses to each other. Basically, gravitational force formula is F is equal to G. Here is the gravitational constant. It has constant value, and it is the product of mass 1 and mass 2. These are the two masses that are opposite to each other, and it's r square per r square. Here r represents the distance. Now gravitational force is relatable to the Coulomb's law. Basically, Coulomb's law states the relation between the charges, but gravitational law states relation between the masses. Gravitational law was measured by torsion balance. It is a type. Here are some key points. Mass of Earth is 6 10 raised to power 24. The density is 5.5 10 raised to power 3. Gravitational constant that I have talked about is 6.67 multiplied by 10 raised to power, it's 10, sorry. It's actually 10. 10 raised to power minus 11. The radius of Earth is 6 10 raised to power 6. And volume of Earth is 9 10 raised to power 20. Diameter of Earth is 1.2 10 raised to power 7. Now we can find the diameter of the Earth by the formula of radius. To find radius, we have formula d upon 2. Now to find the diameter, the 2 will just simply transfer it here and it will multiply by the radius, so we will get the diameter. Now gravitational constant was first introduced by Henry Cavendish in 1797 and value of constant was given by Hall in 1942. Now the second portion is about mass and weight. So there's a huge difference between mass and weight. Actually, mass is the total number of particles in an object. We can say that if this is an object and it contains particles like this, so when we sum up these particles, we can say that that's the mass of this object. But there's a difference between mass and object, that weight depends on the gravity. Like I've talked about, this is mass of an object when the gravity acts on it. We know that gravity of Earth is 9.8. When the force 9.8 acts on it, it will become weight of that object. So we can say that the mass of an object is always constant because it is the total number of particles in it, and the weight is not constant because if we are on moon, gravitational force will be 1.6. That's too much lighter than the gravitational force of the Earth. The SI unit is kg because it is the total particle, or we can say that mass is the total number of matter, so it is measured in kg, while the weight is measured in Newton because there's force of attraction in it and also the mass. So we can say that we just measure the force by Newton. So we can say that to measure weight, we have to just present the value of weight in Newton. It is measured by physical balance. Physical balance is basically an instrument that looks like this. It has a beam and it has two plates on which we can place masses and find its mass. And it is a vacuum that does not have any air resistance, so we can just measure total number of mass very easily. Here is a point. Gravitation is acceleration due to gravity. Sorry, it's capital G. Gravitational force is due to acceleration due to gravity. Oh, I've explained it how it just works. Now the next topic is about quantities or forces types. There are two types of forces, conservative and non-conservative. The conservative force, we can say that does not depend on the path, and non-conservative force depends on the path of the work. Just suppose if a person is walking, he just has a frictional force to walk. It just uses frictional force. Now, the frictional force has a path, while the electromagnetic force or gravitational force does not have any path. So we can say that if a person moves towards the frictional force will be towards. If a person just moves backwards, the frictional force will be backwards. So the frictional force depends on the path of the work, but the conservative force says that it does not depend on the path of the work. So there are only two types of conservative forces in the physics or in the world. First one is gravitational force, because it does not depend on the path, it just exists everywhere. And second one is electromagnetic force. It also does not depend on the path, it's everywhere. If we are producing electromagnetic wave, we can just not say what's the direction of that. While these two things, every quantity, every force has a path. So the conservative depends on path, the non-conservative does not depend on path.